So ratios and proportions, we're going to kind of introduce this topic, but then use it to kind of springboard into similar figures. All right. So a ratio, it's just a kind of a value, but it compares. It's used to compare two measurements or numbers. You dropped something, you see, Sean. Okay. Compares two measurements or numbers. The way you see ratios written, okay, you can see it written as a fraction. That's what we saw in the warm-up. Sometimes it's written this way with a colon between the two numbers, like A to B. But that's so A to B is equivalent as writing it as a fraction like this, A over B. All right. Or sometimes you see the literal English phrase A to B. And these are all equivalent ways to write the ratio of A to B. Okay. So A over B, A colon B, or the phrase A to B gives you that ratio. A proportion, okay, a proportion is an equation. Okay. An equation that states two ratios are equal. Ratios are equal. All right. So, for example, if we have like A over B equals C over D, that is a proportion. Okay, two ratios that are said that they're equal. So two ratios are equal. Okay, and in fact, if this is true, if A over B equals C over D, then A times D is equal to what? C times B or B times C. Okay, exactly right. That's the cross multiplication thing that Mary was kind of like pointing out there. So I'll put that in quotes. That's called cross multiplication. Okay. Now, how do these show up in geometry? Well, one major way that we utilize ratios and proportions is in dealing with similar figures. Now, when we say two things are similar, does that mean that they are identical to each other? Does similar mean like identical? And it does not, right? We have a different idea in geometry for identical. What's the geometric idea about identical? If two things are the same, we say they're congruent. Exactly right. They're congruent. If two figures are the same, exactly the same, we say they're congruent. Similar then means that the two figures are going to be related, but they will not necessarily be identical. Yeah, and that's the key idea. Exactly right, Shannon. So two figures are similar. Okay, if corresponding angles are congruent. Okay, corresponding angles are congruent. Remember, and by the way, just corresponding, right? When we see that, that just means matching, right? If you want to kind of put that up there to remind yourself, corresponding just really means matching angles are congruent. And corresponding sides, okay, or in other words, matching sides, right, are proportional. Okay, so corresponding sides are in the same proportion, or pairs of corresponding sides are in the same proportion to one another. All right, and so I'll do my best here to kind of draw some similar figures. So let's say I've got a statement here. Figure MARK is similar to figure LION. All right. Notice the squiggle here, right? It's just the squiggle. There's no equal sign beneath it. If we put the equal sign beneath it, that means congruent. That means congruent. But just with the squiggle, that squiggle alone means similar. Okay, so Mark is similar to lion. And so I'm going to try and draw. Okay, so we'll call this one M-A-R-K. And then I'll draw a bigger one. And we'll call that L-I-O-N. All right, so since these two shapes are similar, that means that their corresponding angles must be congruent and their corresponding sides must be proportional. So, Stephanie, can you give me a pair of angles that we know are going to be congruent here then? So K will be congruent. So let's just give me, yeah, just one angle at a time. So K will be congruent to what? Yeah, exactly right. Very good. So angle K is congruent to angle N. And give me another pair there, Stephanie.
N, L.
So M and L, angle M is congruent to angle L, and then angle A is congruent to angle I, and then angle R is congruent to angle O. All right, there's all four pairs. By the way, if you have trouble seeing that in the picture itself, you can also go up to the similarity statement, right? Look, M is in the first position, and it's congruent to L, right? There's M and L. A and I, angle A and angle I, angle R and angle O, and angle N and angle K. So they're in the same position there. That also kind of gives it away. And if you want, you can even put the little congruency marks in there. Okay, it gets a little out of control here when you have all four K. But okay, like that. And then also we have corresponding sides. The ratios of the corresponding sides are equal. The proportions are equal there. So let's see here. So Adam, can you give me a pair of corresponding sides?
Segment LN and segment MK.
Yeah, so LN and MK. So I'm going to say MK over LN has to be equal to, and then give me another pair there, Adam.
Segment NO and segment KR.
So yeah, and then I'm going to put KR on top, NO on the bottom. Since I started with my MK on top and then the LN on the bottom, the same thing here. KR needs to be on top still because it's part of that same shape as MK, and then NO will go on the bottom because it's part of the same shape as LN, and it's on the bottom as well there. And we'll do the rest of them here then too, right? So then it would be what? AR and IO, and then MA over LI. If just one of these ratios is not equal to the other three, the shape is not similar. All right, the shape is not similar. So, for example, if MK over LN is like the odd ratio out, all other these three ratios are the same, but MK over LN is not, it's not a similar shape. Okay. So, questions on any of that? Pretty straightforward. All right. If you would then turn to your book, page 601. We're going to jump a little bit ahead of dilations. Well, we will get to dilations later in this unit, but right now I want to just jump ahead to this ratio and proportion stuff. So again, page 601, please. Page 601. Patrick, were you done there? Are you good?
Yeah, I'm good.
Okay. Sorry about that. Page 601. Yes. Yeah, I'll get you a copy if we have time at the end of class, and if not, I'll get it to you on Monday or something like that. Just remind me, okay? All right. So if we look at this shape, all right, look at this little explore here. Okay, we're 11.3, it says corresponding parts of similar figures. Okay, so that's what we're talking about. So the essential question here is, if you know two figures are similar, what can you determine about measures of corresponding angles and lengths? Okay, so we already know that if figures are similar, the side lengths are proportional and the angle measures are equal. If you have two figures with proportional side lengths and congruent angles, can you conclude that they are similar? So if we look here, all right, here's our two shapes. So we're considering the graph of ABCD and then KLMN. All right, now I'm going to measure here with my protractor. And if you guys, if you want to follow along with your protractors, you may, but sadly, my protractors are not here right now. But I think you guys should just be okay with taking my word for it, right? That these are, you guys know how to use the protractor, so I'm not going to make you do that too. So we'll just do this one here first. So it says first, we want to figure out are corresponding angles congruent. All right, so yes or no is the question there. So let's see, we have to find A, B, C, D, and then K, L, M, N. Well, some of these angles we can tell just by looking at them. Okay, so for example, Evan, angle A, what's that measure? Yeah, it's 90 degrees, so we can just like eyeball that and see. And then what about angle D there as well, Evan? What's that going to be? Yeah, same thing. And do you see any other 90-degree angles? Yeah, you got it. Angle K, angle N, they're all 90 degrees, okay? Now, I also want to measure, though, angle B, for example. Now, when I go to measure angle B, unfortunately, that side there just does not quite go long enough for me to be able to measure on my protractor. So what I'm going to do is extend BC here with my pencil, and by extending it, hopefully now I can there we go. Okay, so it looks like it's about, well, let me see here, I can zoom in some. Whose pencil is this? I stole someone's pencil.
No, he's not on the ground.
It's mine now. Okay, I'm going to use it. So we get about, I don't know, like 62 maybe, we'll say, 62 degrees. All right, and then if I measure this other angle here, angle C, also not very nice measure here. Let's see, I'll have to extend that side too, I guess. I'll use this floor pencil here. Let's see what we can get. So I get that to be about, well, let's see here. That's 120, so I don't know, maybe like 118, I'll say. I think that's how it should turn out there, because I think they all should add to 360, so that should work there. Okay. So there's those two measures. Now, of course, if I go to angle L, anyone want to just guess what angle L will probably measure when I go to measure it? Yeah, it's going to be 62 degrees, and of course, M then must be 118 as well. Okay, and if I were to actually measure those, that's the idea there. Okay. So, looks like all the corresponding angles are congruent. Now we're going to look at the ratios of the corresponding side lengths and see if they are, in fact, equal. So, let's do that real quick here. So, Julia, what's the length of AB here in our picture?
It looks like 3.5.
It does look like 3.5. Let's also, though, be careful. Look at the scale here, and this is a little bit tricky. They actually changed the scale on us. So, for example, what is the length of one box?
2.
Yeah, it's 2. So, therefore, if we say 3.5, what's it would be? So double. So double 3.5. So 7. Yeah, 7. Okay. So AB is going to be 7, and then what about KL then, Julia? I counted 7 boxes. 1, 2, 3, 4, 5, 6, 7. So that would be then what? 14. There you go, 14. Okay? 7 over 14. Now, Julia, that simplifies, doesn't it? 7 over 14. Oh, you can't even see my thing here. Hang on, sorry. 7 over 14, that simplifies to what? Yeah, 1/2. Okay, good to know. All right, we'll hold off on the BC and the LM for right now because it's a diagonal distance, but let's go ahead and do CD and MN. So let's see here. Maria is gone, so she gets to miss out on that. All right, Mason, what do you say there? What's CD's length?
4.
Yep, 4, and then MN?
8.
Yeah, 8. Okay, so that would also simplify to what?
1/2.
1/2. Good. And then AD and KN, I'll do that one real quick. So AD is 6, it looks like, and KN, I'm going to guess, is 12. And so that gives us also 1/2. All right, for the diagonal distance here, BC and LM, we kind of have a couple options. We could actually measure it using a straight edge, okay, if you wanted to, and get kind of the measurement using centimeters, and then do it that way. You could also use a distance formula too. Yeah, so the distance formula would also work there. Exactly right. So, but we can probably assume the measure is going to be, well, actually, do we want to do the distance formula here? All right, I'll quickly do the distance formula here. So from B to C, that is going to be the square root of, oh man, this is going to be a pain in the butt. So let's see here, 5 minus 2. Did you get an answer?
Oh, I got 12 points.
5 minus 2. You got 12 points? Oh, okay, hang on a second. We'll get to, yeah, okay, so it's like it's a decimal, huh? So 5 minus 2, and then let's see here, negative 4 minus 2.
I'll do the big one.
Okay, I'm doing the smaller one, so that's good. So then we can check to see if it's double then, if yours answer's correct. So let's see here. 5 minus 2 is 3, squared is 9. Negative 4 minus 2 is negative 6, squared is 36. So square root of 9 plus 36. So about 6.71. So yeah, it'd be the square root of 45, which is approximately 6.71. And then, Tanner, what'd you say you got?
I got 12.36.
For the big one, so 12.36, 12.37. So this one is about half. I mean, if we were so we round here, obviously, and so if I take that 12.37 and divide by 2, I get 6.185. It should be exact. It should be closer than that. All right, let's do the long one here just to make sure. So let's see here. So negative 8 minus 4 squared plus, let's see here, 9 minus 4 squared. Negative 8 minus 4 is negative 12 squared is 144. 9 minus 4 is 5 squared is 25. And so that's 44 plus 25 is 169. Oh, that's
what I forgot to
that's
square.
exactly 13. Right? You forgot to square? Yeah.
Forgot to
Okay.
square the second one.
Okay, gotcha. So then I feel like I may have made a mistake here because this should be 3, 6. Interesting. Okay, well, anyway, it should be exactly half. I'm not sure why I'm getting 6 and 1, 2, 3, 4, 5, 6. So 6 by 12, 6 squared plus 12 squared. I think I may have made a mistake. This should be 9 minus 3 squared, I think, is what I maybe made a mistake on. Alright, well, anyway, it is half, okay? Just take my word for it there. I think I made a mistake in my distance calculations, but I want to keep moving here, okay, just so we can get this stuff in, because we only have about 10 more minutes left anyway before people have to go. So, it's going to be half, okay? So then, can we say, are these figures similar? What's the answer? Yes, the figures are similar. So, yes, okay, corresponding angles are congruent. Okay, and corresponding sides are what? What's the key thing we want to look for? Corresponding angles are congruent, and the corresponding sides, we want them to be proportional. In the same proportion. Okay, in this case, the ratio is 1 to 2, 1/2. Okay. All right, so let's turn the page here. Let's look at the next page. And we'll go through this one much faster, just so we can kind of see it here. All right. So, are corresponding angles congruent in the picture here, or in these two figures? So, So Michael, what do you say here? Are corresponding angles congruent in these two figures?
They seem to be,
Yeah, they look like they're all what?
they look like they're all right angles.
Yeah, so they look like they're all going to be congruent. Now, let's go to the ratios of corresponding side lengths. So, for example, AB here, Michael, what is AB's length? And be careful, again, each box is 2 again this time. So, what's AB's length? 8. And what's EF's length?
14.
Yeah, 14. So that would simplify to, what, 4/7, I think, yeah? All right, now let's look at BC to FG. What's BC's length there, Michael?
6.
Okay, so 6. Uh-huh. And what's FG's length?
10.
10. And that simplifies 2 to what?
3/5.
3/5. And right away, without having to do any more work, are the ratios of corresponding side lengths equal here? Yeah, no. 4/7 does not simplify any further. 3/5 does not simplify any further, and those are not equal fractions. So are the figures similar? No. Okay. Corresponding sides are not proportional. Okay. As soon as you have one oddball ratio, if even one ratio is not the same as the others, not similar. Just takes one. All right, let's look at this next one here. All right, so let's see here. We've got two shapes again. Okay, quadrilateral here, and then another smaller quadrilateral inside of that. All right, again, we want to consider PQRS and WXYZ, and we want to ask the question, are corresponding angles congruent? And so what do we think here? Maria's still not here. Let's see here. So, Zishan, what do you say? Does it look like, well, and I know that we didn't technically measure it, but do we even need to measure it here? I mean, for example, does R look like it's going to be the same measure as angle Y? No. And does it look like R will maybe match angle X? Yeah, it doesn't look like R is going to match any of these other angles here, and so, I'm just going to go ahead and skip all this measurement stuff because we can just kind of see it. I mean, if you wanted to, you could measure with the protractor, convince yourself that it's true, but we can kind of see that they're not going to be the same. So, are the figures similar? No. And what would be our reasoning here, Zishan?
The corresponding angles aren't congruent.
Exactly right. Corresponding angles are not congruent. Ugh. Okay. So again, just to get through that real quick. All right. So let's get into actually like utilizing that then, right, to set things up. So we're going to kind of skip down here. The properties of similar figures, we kind of talked about this, right? If, like, for example, a triangle ABC is similar to triangle XYZ, then angle A is congruent to angle X. B and Y, the two middle letters, C and Z, the two last letters, are also congruent, and then the ratio of the sides are also going to be the same. All right. Something we can do then with just, so that means we don't necessarily need a picture to like identify similarities. We can just use the statement. So for example here, we're told just in words, figure EFGH, not given a picture, maps to figure RSTU by a similarity transformation. That means these two things are similar. And it asks us to just write a proportion that contains EF and RU. Well, if we're going to use EF here, that means EF has to be proportionate to RS. So we put EF over RS. Right? And then EH, first and last letter, matches up with the RU, so that then allows us to, that allows us to then set up that ratio there. So RU is in there with the EH. Okay, notice that EF, alright, so EF is part of that first shape and it goes over the second shape's matching side, and then again, EH from the first shape matches up with the RU from the second shape there. And then also asks to list any angles that must be congruent to angle G. Well, G is the third position, so that is congruent to angle T, and then U is in the fourth position, that matches to H, and so then those two must be congruent. Alright, now here's one for us to fill in, that's what I wanted to get to real quick. Alright, so letter B says figure JKLMN maps to figure TUVWX by a similarity transformation. Write a proportion that contains TX and LM. So there's our proportion with TX and LM. Notice TX is on the bottom, but LM is on the top, right? LM goes on the top, as opposed to tx being on the bottom because lm's from one shape and tx from the other shape. So one has to go on top, one has to go on the bottom. So anyway, all right, let's do this here. So Patrick, tx from here, what does that match up to over here? What corresponds? So tx from this shape, jn is what it corresponds to. And then lm will correspond to what, Patrick? VW, yep, just like a Volkswagen. There you go, okay? VW. All right, and then Melissa, blank is congruent to angle V. So what angle must be congruent to angle V? Angle L. And again, how did you determine that? Yeah, it's in the third position, right? V is in the third position for this shape, so that must correspond and be congruent to angle L. Very good. And then what about the other angle K there, Melissa? What's that one going to be congruent to? Angle U. And again, by the similar kind of argument. That's right. Okay? All right, so real quick, I just want to show you one more thing, okay, and we'll just walk through this because I know some of you guys got to leave here in a few mere minutes. All right, so how are we going to be using this? Okay, so for example, 2 here, we've got 2 congruent figures. We're told, it's not congruent, sorry, we're told they're similar figures. So that means their angles are congruent, their sides are proportional. So for example here, we're in letter A, we're asked to find the value of x. So here's the only x term that we've got, 4x plus 27, and that's angle C. Well, angle C corresponds to angle R here, so that means we can set 4x plus 27 equal to the 95, and solve for the x, and you get x is 17. Okay? To find y, it's a little bit trickier because you have sides now. The 3y minus 5 here in the big shape, what does that correspond to in this smaller shape? Anybody? 3y minus 5, the AD side here, what does that correspond to in this smaller shape? The what? The 5, yeah, the PQ or 5, exactly right. So you can write 3y minus 5 over 5, which is what they did right there. And then clearly the 4y corresponds to what over here? The 10, so 4y over 10. Then you just cross multiply. Be careful when you cross multiply here. The 5 times the 4y, that gives you 20y. The 10 here, when you multiply, what does the 10 multiply to when you multiply it to the 3y and the minus 5? Don't worry, guys. I promise the bell will not, you won't disappear or anything like that. I promise you'll get to the pep rally, no problem. The 10, when we multiply it to the 3y minus 5, what gets multiplied by the 10 there? Well, just wait. We're going to finish this, and then you can go. I promise. Don't you worry. They're not going to. The pep rally. Well, they'll hold the pep rally until you show up. Like
The whole thing?
yeah, the whole thing. 3y and the minus 5, so it equals 30y minus 50, and then you guys can solve that equation from there, and you get y equals 5. Okay, your homework for those who are leaving me is going to be 1, 2, 3, 4, 5, and 6. Okay, on page 606. I'm also going to have you do 15 and 16 as well on the next page, all right? And we'll just call that.
Hey, what's the page?
So 606 to 607.